So in this topic, I am going to start one of the most complicated topics in physics, namely rotational dynamics. So actually, before we go into this topic, we must understand certain types of motions. First, we have what is called translation. Sometimes it is also called translatory motion. Then we have what is called fixed axis rotation. Fixed axis rotation. Then we have what is called plane motion. Okay, plane motion. These are the three topics which are important for our IIT JEE examination. But once you go into IITs, you will also be dealing with rotation about a point. Rotation about a point. Then we will also be discussing in IIT, in the IITs, in the first year or maybe second year of IIT, what is called general motion of a rigid body. General motion of rigid body. So this general motion means three-dimensional general motion. So 4 and 5 we won't be discussing 4 and 5 in our course because they are very complicated. In fact, we will discuss only 1, 2, 3. That itself is very complicated. To discuss 1, 2, 3 thoroughly is very tough, to understand, because there are so many concepts in rotation. So let's see what is translation. So our first motion which we are going to discuss here is translation. So what is translation? Suppose I have certain object, maybe a stick. Let us say this is a stick. What I will do is I will choose two particles on the stick. Those two particles could be any two particles arbitrarily. So I will choose one particle A, other particle B, and I will join these particles by a straight line like that. Now if the stick moves in such a way that line joining these two particles does not change its direction. Okay, so the stick should move in such a way that line joining these particles should not change direction. For example, if the stick came to this position, the line joining A and B is still vertical only. Then we say the stick has translated. Okay, so take any 2 points on the stick, join them. The stick should move in such a way that line joining the particles must not change direction. Then we say it is translatory motion. Okay, so for example, after some time if you see the stick in this position, it is no more translation because line joining the A and B has turned by 90 degrees. The line joining A and B particles was straight, vertical, now it became horizontal. Okay, so this is not translation. So for example, I can define translation in this way. I'll write a normal statement. Choose any 2 points on the particle. Choose any two particles on the body. Choose any 2 particles on the body. The word any means I can choose any arbitrary 2 particles. The line joining the 2 particles, okay, must not change direction as particle moves. Must not change direction as the particle moves. Okay, so the line joining the two particles must not change direction. Sorry, as the body moves. I'm sorry about this. As the body moves, then we say it is translation. For example, I can have a stick which was like this, then it went to that position, then it went to that position, then it came here, then it came here, then it came here. If you see, you might say the stick went in a curved path like that, but still this is translation only. Even though the stick would have gone in a circle, this is translational motion, because you take any two particles on the stick, the line joining them does not change direction. Of course, if the stick goes in a straight line, we call it rectilinear translation. Rectilinear translation if the stick goes in a straight line. If it goes in a curve, as I have shown in this diagram, that is called curvilinear translation. Curvilinear translation. Okay, so you might say the stick is going in a circle in this case. I will also name the points on the stick A, B, A, B, but actually it is undergoing only translatory motion. That is the idea here. Now the important point in translatory motion is, if you observe the velocity of all the particles at some instant, they will all be same, because all the particles are trying to move in the same direction. So one important feature of translatory motion is, when an object translates, when an object is undergoing translatory motion, all particles have same velocity, at any arbitrary instant of time. Can you visualize this statement? When it is moving in translation, all particles have same velocity. If you observe it at any moment, at 3 o'clock, let us say you are observing a body which is undergoing translation. At that moment, at 3 o'clock, all these particles have some velocity, let us say 4 meters per second in a particular direction. Then you observe again at 5 o'clock, all particles will have same velocity, let's say 10 meters per second, again in some particular direction. So I can also define translatory motion as a motion where the velocities of all the particles are same at any chosen arbitrary instant. Okay, so I can define translatory motion even in this way. So translatory motion is one where velocities of all particles are same at any given instant. So all the particles will have same velocity at the moment you are observing. Again, after some time, they will again have same velocity, but the velocity can change from time to time. Suppose right now all particles have 4 meters per second north velocity. Tomorrow they may have 5 meters per second south. It's okay. But all particles have 5 tomorrow. All particles have 4 meters per second today. That is the meaning of translation. So I can say, when a body is translating, suppose I draw some body, this particle has velocity VA and this particle has velocity VB, then I can say VA equal to VB in both magnitude and direction. This is the condition for translation. Obviously, if VA equal to VB, then even their rate of change, that means their accelerations, must also be same. So if velocity of particle 1 changes by certain amount, velocity of particle 2 must also change by same amount. Okay, whether in magnitude or in direction. This is the meaning of translation. So in translation, if you take any two particles, they will have same velocity, same acceleration. That is the meaning. So when a body is translating, any two particles in the body have same velocity, same acceleration. This is all there is to translatory motion. Okay, as far as the concept is concerned. Of course, it's very deep. We will see the implications of all what we are listening now later in problems. Now let's go to fixed axis rotation. Okay, I'll erase this slide, all these slides. So let's go to now fixed axis rotation, this motion. So here there are three terms: fixed, axis and rotation. So we must understand what is the meaning of axis. We'll understand it in a minute. So suppose there is a body and all the particles of the body are moving in circles. Okay. So let us say there is a body, all particles on this body, all particles of this body, I can say, are moving in circles. Okay, and the centers of these circles, the centers of all these circles lie on a fixed straight line. Then we say the body is undergoing fixed axis rotation. Then we say the body is undergoing fixed axis rotation. What is the meaning of this? And this fixed straight line is also what is called axis of rotation. This fixed straight line is called axis of rotation. So let's see this in a bit more detail. First, all particles of the body must be moving in circles. They must be going in circular motion. That is the number one criteria. Then the centers of all these circles must lie on a single straight line. That is the second criteria. And that straight line should not move. It should be fixed. In fact, that straight line is called axis. So one best example is fan. For example, we have the fan which is rotating. Okay, we have fan which is rotating. If you take any point on the wing, it is going in a circle. If you take another point, so I am taking here 2 points. One is A, other is B. A is going in a bigger circle, B is going in a smaller circle. But all points on the fan are moving in circles. And the centers of all these circles lie on a straight line, an imaginary line, which you can visualize as if passing through the center of the fan. So all points are going in circles around that straight line which passes through center. Okay, so that straight line, that is called axis. In fact, that axis is not moving, so it is fixed axis. So in fixed axis rotation, all points on the body move in circles and centers of all these circles lie on a fixed straight line called axis. Okay, so that is fixed axis rotation. So basically all points are moving in circles, centers of all these circles will lie on a single straight line which is not moving. That straight line itself is fixed. For example, if you lift a car into air, if you lift a car into air and let only the wheels rotate, the car is not on the ground, it's in the air and only wheels are rotating. So I can say the wheel is undergoing fixed axis rotation because all points on the wheel are going in circles around a straight line and that straight line is not moving, which is the axis or axle of the wheel in fact. Of course, when the car moves on the road, it is not fixed axis rotation. It is moving axis rotation actually, because axis is also moving. The straight line passing through the center of the wheel also moves on the road. Okay, for example, the wheel was here and it was rotating. After some moment the wheel is here. Okay, so the axis which I represent with a dot coming towards your eye, a line passing through the center of the wheel coming towards your eye is the axis. The axis has moved, so it is a moving axis rotation. So If a car is going on the road, the motion of the wheel is moving axis rotation. But if the car is in air and only the wheel rotates, a very strange case, then we say it is fixed axis rotation. Now, we have learnt about fixed axis rotation, variable axis rotation, translation, rectilinear translation, curvilinear translation. It's time to go into what is called plane motion. So let's go into what is plane motion. Okay, I will erase this slide. Plane motion is a very strange motion. Actually, I can say plane motion, it is combination of translation plus fixed axis rotation. I can say this is one definition of plane motion. If a body moves in such a way that it is combination of translation plus fixed axis rotation, it is plane motion. Or I can say the body moves in a plane. The body moves in a two-dimensional, 2D, what I call as plane. Or I can also define it in another way. If distance of all the points on the body is constant from a fixed plane, if distance of all the particles of the body is constant from a fixed plane, then it is undergoing plane motion. It is undergoing plane motion. That is the meaning. How to visualize this? Very simple. Suppose I have two walls like this, and there is a stick which is sliding between the walls. This is a stick. After some time, the stick will come to a new position like that. It is sliding between the walls. So the stick is moving in a plane. So it is a plane motion. Plane motion. Or for example, a wheel is moving on the road. It is rotating as well as moving like that. So after some time you will find the wheel here. It is moving in a fixed plane. I can say it's a plane motion. Or if you have a wall which is parallel to the direction of wheel's motion, the distance of the wheel from the wall is always constant. So let us say there is a big wall, and by the side of it you are taking a wheel along the wall. Okay, so the distance of the wheel from the wall is always constant. So that is plane motion because it is moving in a plane. Okay, so plane motion can be considered as translation plus rotation. This is a very important concept. In fact, this logic, the plane motion is translation plus rotation, works fantastic in rotation in our topic. So let's see. I'll take the example of a stick and show you how plane motion is translation plus rotation. So I have this stick which I call it as AB. After some time, the stick came to the new position like that, which I am showing by A dash, B dash. Okay, the stick has slid and it has come to new position. Maybe I must draw it in a better way. So like that, it came to A dash, B dash. So it has moved in a plane. I can call it plane motion. How can I represent this plane motion as a translation plus rotation? Translation plus fixed axis rotation. How? First, choose a point on the stick. Let us choose A. So first I will translate about A. So that means the stick should move in such a way that line joining any two particles on the stick must not change direction. So A came to A dash, the stick came to this position. Okay, shown by the dotted line. Stick came to that position. So I have translated the stick. So the stick AB came to A dash, I can say B double dash by translation. So I have chosen a point on the stick, I have translated the stick about that point. Okay, then I'll fix that point, fix A dash, rotate the stick to bring B double dash to B. Okay, so first I translated the stick by choosing some point on the stick. Okay, I brought the stick to new position. I brought the point A to new position using translation. Then I fixed A and I rotated the stick using fixed axis rotation and brought the stick to new position. Okay, that is the whole idea of plane motion. I'll draw an appropriate diagram. So this is B double dash. So first I translated the stick from AB. The stick came to A dash B double dash. Then I fixed A dash and rotated the stick in counterclockwise direction to bring B double dash to B dash. To bring B double dash to B dash. Or I could have done it differently. Okay, first I could have translated about B. That means I will take B to B dash. So I am translating the stick so that it is coming to this position. So what happened? I am translating it about B. What do I mean by translating about B? Move B to B dash by translating the stick. Then fix B dash, rotate the stick in counterclockwise direction to bring A double dash to A dash. So ultimately what is my aim? To bring the stick from AB to A dash B dash. And I am visualizing it as a two-step process, though both steps happen simultaneously. One step is translation, the other step is rotation, fixed axis rotation. Both are happening simultaneously actually. But for my convenience I am splitting it. So first I will translate the stick about A. That means I will bring A to A dash by translation. Then I will fix A dash and rotate the stick, which is fixed axis rotation, to bring it to new position. Or I can translate about B by moving B to B dash. Then I will fix B dash and again rotate the stick in the same counterclockwise direction to bring it to new position. So in either way you are translating about some point, then you are fixing that point, you are doing fixed axis rotation about that point, and the stick comes to new position. So when both happen simultaneously, translation and rotation, okay, then you get plane motion. So I want you to visualize this. Imagine first the stick is translating from AB and it is coming to A dash B dash by translation, A dash B double dash. Then you fix A dash, rotate the stick in counterclockwise direction to bring it from A dash B double dash to A dash B dash. Or move the stick AB to A double dash B dash by translation, then fix B dash and rotate the stick from A double dash B dash to A dash B dash. Okay, it is very difficult to explain on a video, but I hope you got the point. I can also show it. You can also choose center of mass of the stick, translate first and bring center of mass to the new position, then rotate by fixing center of mass. So you choose any point on the object, first bring that point to the new location by translation, then fix that point and rotate to bring the whole body to new location. Okay, for example, I have a wheel, which this is the center, this is point A, this is point B, and after some time the wheel came to this situation. Center is here, A went up, B came to the left. So this is also a plane motion because the stick is moving in a plane. Now how can I split this into translation plus rotation? First we will do the simplest. Translate about center of mass, means drag the wheel and bring it to the new situation with centers coinciding. So if you simply drag the wheel, B would have still been at the bottom, A would have been still here, but center came to new location. Then fix the center and rotate the wheel clockwise so that A goes to the top, B comes to the left. So I have done translation first, dragged the wheel by translating, then fixed the center and rotated the wheel. So translation plus fixed axis rotation. You can also do it about B. First bring the wheel so that B comes to the final situation. Means it will come to that. So I have translated the wheel so that B came to the new location. Then fix B and rotate the wheel by clockwise to bring it to new situation. So you can choose any point on the body, translate about that point, fix that point and rotate about that point. So this translation plus rotation is equal to plane motion. It's a very powerful concept, very important concept. So plane motion is simply translation plus fixed axis rotation. In fact, when we go more deeper into rotation, for example, when we want to write kinetic energy of a body in plane motion, it is kinetic energy in translation about center of mass plus kinetic energy in rotation about center of mass. We always take center of mass, find kinetic energy due to only translation, find kinetic energy due to only rotation and add both. You will get total kinetic energy. Similarly, angular momentum, we introduce a quantity called angular momentum in plane motion. It is angular momentum in translation and angular momentum in rotation. I mean, we can split it that way. It's a very convenient concept. So plane motion is translation about some point on the body, then fix that point and fixed axis rotation about that point of the same body. You might ask, what if I choose a point which is outside the body? Can I translate and rotate it about that point? Well, you add a massless rigid extension to the body. Okay? Include that point which is outside the body. Include that point as if it is in the body by adding a massless rigid extension. Then you do translation plus rotation. That works. So, I have discussed up till now translation, fixed axis rotation and plane motion. I'll discuss briefly about the other two also. Rotation about a point means there is one point in the body which is fixed, which doesn't move. All other points can move in any way you want. Okay, this is called rotation about a point. For example, you take the motion of a top, okay, a rotating top, top. The bottommost point of the top is attached to the ground. It doesn't move. Then the top rotates, it also wobbles. Okay, it is rotating and also turning. You can try this as an experiment. So bottommost point is fixed. All other points are going in very complicated motion. So it is rotation about a point. Okay. For example, I can draw a top here like this. Okay, it is rotating. This bottommost point is fixed. Then the axis of the top is also not fixed, it is rotating. For example, at some point the top will be in this situation. Okay, I would like to show it with a different color. At some point the top would be, okay, this is the axis. Then at some other point the top would be like that. Okay, now the axis is this, but you see the bottommost point is not moving. Okay, and the top is rotating. So this is a type of motion which comes under rotation about a point. Okay, then general motion of a rigid body is any other complicated motion, and it can get as complicated as we want. And this is the most challenging in rotation, which you will do in your first year of IIT. Okay, when you join any IIT, in my belief they will teach you this in first year. When I was in IIT Delhi, the Department of Applied Mechanics gave this course to us, and it was a very tough course, and I was really struggling with it. So anyway, you will learn that in your first year, and there are very good books available on these motions also, which you can go through. So this is our first introduction to rotation. From here onwards, our topics that we are going to discuss will be in this order which I am going to write now. So we discussed about translation, fixed axis rotation and plane motion. Now I will introduce omega, which is nothing but angular velocity. So definition of angular velocity. This itself will take one lecture. It's not easy to define angular velocity as most people think. It is the most complicated subject on earth. Then I will also talk about moment of inertia. This is one separate topic on its own, which will take a lot of time. Then we must talk about angular momentum and torque, which is a separate topic on its own. There are many complicated issues with angular momentum. Then we must talk about rolling motion, which is another separate topic, and I must talk about kinetic energy in rotation. And then we have to club all these topics also. There may be many other small topics, toppling, etc. Then we have to club all these topics and do problems on that. So this can get as complicated as it's already a very complicated subject, and this can get very complicated. It is not easy. So rotation is one of the challenging topics in physics in IIT JEE. So I will try to do the best I can and try to help you understand this complicated subject. So I'll stop this lecture here. Thank you. My name is Kalyan Dutt, and I did my BTech in electrical engineering from IIT Delhi, and I stay here in Hyderabad, where I am recording these lectures on my iPad. And if you have any doubts, you can post comments to my video lectures, and I'll try to reply depending on my free time. Okay, thank you.